variables, operators, and built-in functions in programming language Visual Basic for applications. The task. Make algorithm and write Visual Basic program for the first. Display the result of expression calculation. Y. The number of characters in the user-entered string S. B. Number of degrees entered by the user. The second. Display an uppercase fragment of the string S, from the first to the penultimate character. Create a new Excel spreadsheet file. Put the mouse pointer over the Microsoft Excel ribbon, any empty place. Call the context menu, on the ribbon. Select Customize the ribbon item. Let's look at the list of available ribbon tabs. Set visibility of the Developer tab on the ribbon. Save ribbon settings. Check the Developer tab visibility. Open the Developer tab, clicking on its name. Open Visual Basic Programming Language Editor. Create a program module, in the Visual Basic environment. Open the Insert menu item. Run the module command, to add a program module to the Microsoft Excel file. We see the added module in the editor window. Information about the module is also displayed in the project window for the current Excel file. Save the spreadsheet file. We refuse to save without the support of macros, Visual Basic programs. Expand the file type list, to select the desired save option. Choose the macro-enabled save option. After checking the file name and type, we will save the spreadsheet. Let's start forming the program, with the implementation of the corresponding block of the algorithm. Type the sub-instruction, with the program name PR2. Define the completion block of the algorithm. Type the end sub-statement. Define an algorithm block, for entering the value of the variable s, by the user. We implement the block with the function input box, with the parameter, the text string of the message for the input window. The result of the user's input will be placed into the s variable. Let's run the program for execution. The window, specified in the program for user input, is displayed. Enter the value in the text box. Confirm the input, completing the input box command of the Visual Basic program. Add the option explicit statement before the program, which requires a mandatory declaration of all variables. Run the program. If the cursor was not set between the sub and end sub instructions before starting, we get a dialog to select the program to run. Select the program to run. The error is caused by the lack of a description of the s variable. This is required by option explicit. Close the message window, and proceed to describe the s variable. When the program crashes, it stops before the error line, hangs. To continue editing, the program must be reset. Let's write the dim instruction to create the s variable. The string parameter defines the storage of a string of text in a variable. Run the program. Type the value using input box dialog. The program worked correctly. Add the value of the variable b to the existing block of the algorithm. We implement the input box function to enter the value of the variable b by the user. The variable b must be described using the dim statement with the single parameter. This parameter defines the storage of real numbers in a variable. Save the spreadsheet file with the program. Run the program. First, the program prompts you to type the value of the variable s. Then we get a window with a field for typing the value of the b variable. After the variable input block, we will set an action in the algorithm to calculate the number of characters in the string s. The result is written to the a variable. To calculate the number of characters in a string, we use the len function with an argument, the s variable containing the string. The value returned by the function will be written to the a variable. The a variable must be described, using the dim statement, with the integer parameter. This parameter defines the storage of integers in a variable. We plan to organize control over the values of variables when debugging the program. Set the mouse pointer over the s variable, and select the Add Watch command in the context menu. Confirm the setting of control over the s variable. We will notice the appearance of information about the s variable in the Watches window. Similarly, we will also establish control over the a and b variables. Place the cursor in the text of the program, and run it in step-by-step, line-by-line mode, by pressing F8. After each press of F8, one line of the program is executed. In this case, the line that is preparing for execution is highlighted in color. Simultaneously with the execution of the program lines, the current values of variables are displayed in the value column of the Watches window. When the corresponding line of the program is executed, we get a window for entering the s variable. After entering a value in the s variable, information about this appears in the value column of the Watches window. After pressing F8 again, the program line is executed to typing the b variable. We observe a change in the value of the b variable after user input. After executing the next line, by pressing F8, check the value of the a variable. It should be equal to the number of letters in the value of the s variable. The program terminates only after executing all its lines, including the last one, end sub. After the execution of all lines of the program is completed, all the variables in the Watches window lose their values. The involved random access memory is cleared. Let's start calculating the y expression with one of its fragments. We apply the function cos with the parameter b variable to calculate the planned block of the algorithm. The parameter of the cosine function is considered a value in radians, so the value b, entered in degrees, must be converted to radians. In this case, to calculate the constant pi, the function atn, arctangent, with the parameter 1 is used, which returns 45 degrees in radians. To raise the function cosine to the power of 3, we use the operator caret, power. Let's continue calculating y, by subtracting a random number, from its current value. Let's use the R&D function, to set a random number. The R&D function sets a random number in the range from 0 to 1, so to change it, in accordance with the task, you need to multiply the function by 5, and subtract 2 from the result. The R&D function returns a real number, so to get a random number as an integer, you need to apply the rounding function to it. In order for the R&D function to generate non-repeating random numbers, every time it is run, it is advisable to use the randomize instruction before using it. Let's continue calculating y, by determining the modulus of the current value. To calculate the modulus of the expression, the ABS function is used. With the dim instruction, we declare the used variable y, as well as a new y1, for calculating the denominator of the expression. Let's define an algorithm block, for calculating the logarithm on a given basis. Visual Basic has a log function, for calculating the natural logarithm, so we use an expression in the program, to calculate the logarithm on an arbitrary basis. Let's define an algorithm block, for calculating the remainder of dividing the exponent, by the calculated logarithm. Consider the program line, for calculating the exponent, and the remainder of the division. The function exp calculates the power of the constant e, given by the argument. The mod operator calculates the remainder of the division, of the expression operand in front of it, by the one following it. Let's define an algorithm block, for the final calculation of the value y, basing on current y and y1. Let's write a string in the program, for the final calculation of the given expression. Let's set control over the values, y and y1, using the context command, add watch. After placing the cursor in the text of the program, run it in step-by-step, line-by-line mode, by pressing F8. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. When executing the corresponding lines, we will type the necessary values. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. When executing the corresponding lines, we will type the necessary values. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. Simultaneously with the execution of the program lines, by pressing F8, we observe a change in the values of variables in the watches window. After executing the line end sub, we observe the absence of variable values in the watches window. Let's define an algorithm block for selecting a fragment of the source string from the first to the penultimate character. Use the mid function to define a string without the last character. The mid function has three comma-separated parameters. The first parameter is a variable with the original string, or the string itself, placed in quotation marks. The second parameter of the mid function is the number of characters in the string, starting from which you want to take characters. The third parameter of the mid function is the number of characters that must be taken from the string, specified by the first parameter, starting with the character specified in the second parameter. Since the characters before the penultimate are required, you should specify the number of characters per one less than the previously defined in the A variable. Let's define the algorithm for converting of the received fragment of a string in uppercase. Use the ucase function to convert a string of characters to uppercase. We pay attention to the fact that in one line of code, on different sides of the equals sign, the same variable is used, on the right, with the old value, on the left, with the new, after reassignment. Let's define an algorithm block for displaying the result of calculating the y expression and the converted string fragment s. The output of the values of the y and s variables is organized in the program by the command message box. The parameter of the message box command is the output string, which can consist of several parts, two, in our example, connected by the AND operator. Run the program. Let's enter the initial data, the value of the s variable. Let's enter the initial data, the value of the b variable. Note that in the final message, the two results visually merge into one. Add the part, separating the values of the y and s variables, to the output string. We use a string space as a separator. Run program again. Let's enter the initial data, the value of the s variable. Let's enter the initial data, the value of the b variable. Result message is better for reading, but there is no information about which variables correspond to the displayed values. Let's add immutable parts to the output string, in which we specify the names of variables, for which values will be displayed. Run the program. Let's enter the initial data, the value of the s variable. Let's enter the initial data, the value of the b variable. The message is practically normal. The only thing that might make sense is to round the result of a numeric value. Add the round function to the output of the value of the numeric y variable, the first parameter of which will be the variable itself, and the second, the number of decimal places. Run the program. Let's enter the initial data, the value of the s variable. Let's enter the initial data, the value of the b variable. The result message has the form we need. Save the spreadsheet file.